So the next topic is exception handling. So till yesterday we have finished OOPS concepts and another step in the advanced core Java, exception handling, file handling, string handling, collections. These are the topics left. So exception handling means, okay, so you have written a code and in the middle, your program terminated. You don't know why it got terminated, and it's very difficult to understand that. So in order to handle such kind of scenarios, runtime errors, so we need to use a concept of exception handling. So if there is an exception in the program, handle it. Then how do we know that? So there are some scenarios, you know that those scenarios comes, you can write that exception handling concepts. So I'll give some of the tips and better to include in our code. So basically, we'll use these concepts in between the inside the method body. So that's exception handling only. We are not learning something new topic. Already methods topic only. Inside a method body, we'll writing the logic. So there are some scenarios. That scenarios might give you exceptions. So in order to handle them, so we need to learn this exception handling concept. Okay, so what is exception handling? So it is one of the best concept in any programming language to handle the runtime errors. Runtime, we are not going to be stayed there. So to handle the runtime errors, and so that normal flow of your program execution will be maintained if you handle the exceptions. That is called exception handling. So what is exception? Exception is unwanted, unexpected event. So you don't know when it occurs. That unexpected event, so which occurs during program execution. So basically it disrupts your program execution in the middle. So your program will stop. So normal flow of your program will stop there only, and further it won't continue. If that is called exception. So what is the difference between error and exception? An error indicates that so serious problem, that is a reasonable. So applications should not try to catch. We cannot catch that if error is there at runtime. But yeah, you have to solve that problem. But exceptions, you can catch them. So exception is an unexpected event. You can catch that. That is called exception. So when exception occurs, program will terminate on that line only. In such cases, we get a system generated error message. We won't understand that system generated messages. In order to understand very clearly why it is failing and provide a meaningful message to the user, so then you can apply the exception concepts. Why exceptions occurs? There are several reasons for exceptions. So opening a non-existing file in your program. Maybe in your code you have written open the non-existing file. That might cause the problem. Network connection problem. Bad input data provided by user. So these are all so reasons for exceptions. And we'll see that there are some other exceptions also. We will learn one by one. So what is the hierarchy of exception classes? The exception classes hierarchy is, so basically it is available in java.lang package. Throwable is the root class of exception. So, and throwable again divided into exception and error. And the throwable root parent is object class. Throwable parent is object. So throwable is divided into exception and error. Exception again categorized into two types. Two types of exceptions are there. Checked exceptions, unchecked exceptions. So the classes which extends to throwable class other than runtime and error is known as a checked exception. The classes which extends to throwable class other than runtime and error is known as a checked exception. So checked exceptions occurs at a compile time only. That means while writing the code itself, you will get these checked exceptions. So we have such exceptions, example, IO exception, SQL exception, class not found exception. That's the checked exception. Checked exception also called compile time exception. There is a runtime exceptions. Runtime exception means or unchecked exception. Unchecked or runtime exception. So runtime exceptions are the classes which extends to runtime exception. So are a exception class or a throwable class. So which are runtime exceptions? These are the runtime exceptions. Arithmetic exception, null pointer exception, number format exception, array index out of bounds exception, string index out of bounds exception. These are the runtime exceptions. So these occurs at only at a runtime. After running your program, then only you will get these exceptions. Even though if you have exceptions, these exceptions at compile time, they won't complain. They will throw at runtime only. Then there is a error. So error is irrecoverable and you can solve them by just giving proper code and data. So stack overflow error, virtual machine error, out of memory error, assertion error. These are all the examples for error concept. And so we already discussed this part. So what are the common scenarios of Java exceptions? There are few scenarios are there. Why you will get this runtime exceptions, we'll see that. When you will get arithmetic exception. So the first one is arithmetic exception. So scenario, when you will get arithmetic exception scenario. Generally, if you divide any number by 0, there occurs an arithmetic exception. If you divide any number by 0, then you will get a arithmetic exception. So int a equal to 50 by 0. So that means you are dividing a number by 0. So that throws, if you write like this in your code, this line will throw arithmetic exception. Any number. So if you write like this, that line will give you arithmetic exception at runtime, not when you write the code. So while execution after, you will get this arithmetic exception. Second one, null pointer exception. Null pointer exception. If we have a null value in any variable, performing any operation on that null variable, then throws null pointer exception. So string s equal to null, and see I am on this variable. I am so calling the length method. String method I am calling. So because it is a null, this variable has a null value. On that null variable, I'm calling the methods. Methods are variables. If you call, this will give you null pointer exception. This is the common exception used to see this. Easily can catch. So null pointer exception you're getting is something is null. So it should have some value, but there is a null value. So there is a null value. That's the null pointer exception means. So number format exception. Number format exception. So wrong formatting of any value may occur number format exception. So wrong formatting of any value may occur number format exception. So suppose I have a string variable that has characters, no. So you're trying to convert this variable into digit. So now this is the string, right? Double quotes inside means it's a string. If you convert string into integer, that will throw number format exception. So string s equal to abc and int I equal to integer dot parseInt. So that will throw number format exception. That will throw number format exception. So that's a number format exception means. So this is another, commonly you will use this code. So how can you convert string to string object into primitive integer format? So the answer is you have to write. So this method data type is a integer data type. I equal to integer wrapper class dot parseInt method. The parseInt method you are passing string object. So, and this will throw a number format exception. Why? Alphabets you cannot convert into integers. That you are doing a wrong formatting here. That's why you will get a number format exception. So there are no parseInt method. This is the wrapper class. So wrapper classes, let me show you wrapper classes. So wrapper classes are used for converting primitive data types into objects like int to integer, long to long, float to float, double to double, all this. So there are 8 primitive data types as 8 wrapper classes. So these are the one, Boolean, a Boolean wrapper class. Character wrapper class. Byte wrapper class. Short wrapper class. Integer wrapper class. Long, float. So these are the primitive data types, right? And 8 primitive data types has 8 wrapper classes. So this is the primitive data. To represent the primitive data, you will use this primitive data types. If you want to represent the objects or you want to convert a primitive data type into object or object into primitive data type like this, I'm converting here object into primitive format. So that means both vice versa. Primitive data you can convert into object format. Object you can convert into primitive format. That is possible with the wrapper classes only. So in order to achieve that, we are using wrapper classes. So why do you need wrapper classes? So you can change the value. You can change so primitive value into object value into primitive. That's the first one. So serialization. So you want you want to convert the objects into streams to perform the serialization. You will use this wrapper classes. In the collection framework, so it works with only objects only. Collections will work with only objects. So all the classes deal with objects only. In order to deal with objects, you need to use, so number object you want to represent. You cannot use these primitive types. You have to use these, so integer or long or float, whatever it is. So these classes only you have to use. That purpose we'll use these wrapper classes. Simple. See, hash map. You cannot use the primitive data type. See the data type of key value pair you're representing. Key is an integer data type, value is a string data type. So in order to do that, you can use only wrapper classes, not primitive. You cannot write like this. See this is the invalid. Why it is invalid? I am using primitive. That's wrong. But you have to write like this. So array list. So you have to write like this. So in order to do that, you need a wrapper classes. There is auto boxing and unboxing. Auto boxing means automatic conversion of primitive types to the object. So that is called this auto boxing. Conversion of int to integer, long to long, double to double, that you can do with auto boxing. So that's a auto boxing means. Converting primitive type to wrapper object is called auto boxing. This is the one. So this is the primitive data, right? Int num equal to 100. Now I can convert into object. How can I convert into object? Integer wrapper class dot value of the primitive number. Then it will convert into object. So this is how you can convert. That is called converting primitive into object is called auto boxing. So there is unboxing. Unboxing means automatic conversion of wrapper type into its corresponding primitive type. Now this one. So the object you are converting into primitive format. That is called unboxing. This is called unboxing. You are doing unboxing. Okay. So that's the auto boxing and unboxing you need to understand. Auto boxing means converting the primitive into object. That is called auto boxing. And when you are converting object into primitive format, that is called unboxing. Now this is the unboxing example. Object you are converting into primitive. That is called unboxing. So you have every class, there is a parse method is there. Parse method is there. So that's a number format exception. When you're trying to do a wrong conversion, it will throw number format exception. So there is a array index out of bounds exception. I already explained and given examples. Array index out of bounds exception means, so if you are inserting any value at wrong index, it would result array index out of bounds exception. Suppose your array size is 5, but you are inserting at a wrong index, that will throw, this line will throw array index out of bounds exception. Okay, so these are the few scenarios why you will get an exception. You are writing an invalid code. You are making some mistakes in the code. That will throw a number format exception. You should know this, okay? Oh, null variable, on the null variable, you should not call the methods and variables. Then, okay, initially you can declare null, but assign the value later. Assign the value later. So that is called null pointer exception means. That will throw null pointer exception. Okay, so all these points you need to remember so that you can easily solve those and you can include the try catch blocks. There are exception concepts. We can handle that. Okay, you got the scenarios why you will get an exception. Now, how can we handle them? To handle them, so we need to use a try, catch, finally, throw, and throws keywords. So these are the 5 keywords you will use to handle the exceptions. So how to handle these exceptions? Try, catch, finally, throw, and throws keyword we'll use. That's the Java try, catch, finally, throws keyword. Let's understand first Java try block. So Java try block is used to enclose the code that might throw an exception. So where the exception occurs, that piece of code you enclose with a try block. Block means, curly brackets, right? So try, and then the statement where it is giving an error, that you enclose in the try block. Then immediately you write the catch block. Catch block object type you have to mention, okay? Which type of class? What type of exception class? Then that object reference you give here. Then object reference dot, you can call print stack trace method, get message method, get cause method. All these methods you can call to get a clear message and which line you are getting error. Everything complete stack trace will be given to you. That is the advantage by handling try catch blocks, so that it will pinpoint where you are getting this error except exactly which line you are getting. So for example, you have nested methods. You call method inside another method, another method, another method, like that. Multiple methods you are calling, and one method chain to other method, one method calling other method, one method calling other method. Like that, you have multiple chains. And you should know, okay, each method, which line is causing that problem. That everything will be pinpoint if you handle this try catch blocks. That's the advantage of try catch blocks. So the Java try block is used to enclose the code that might throw an exception. It must be used within the method only. If an exception occurs at a particular statement of try block, the rest of the block code will not execute. Rest of the block code will not execute. So it is recommended not to keep the code in try block that will not throw an exception. So if some line is not throwing exception, don't keep inside the try block. Okay, so otherwise it will skip. For example, before that line, you got an exception. Then the line which is not affecting, that also will skip. So you should not write the line which is not throwing an exception in the try block. Only which line is throwing an exception, that you keep in the try block. And every try block must be followed by catch block or finally block. Either catch or finally block. You can so like this. This the try is followed by catch, right? Here try can be followed by finally also. Or you can write try, catch, then finally. So all three also you can write. Once you understand finally, you will come to know what is meant by final. Let's understand catch block. Are you clear on the try block? Yeah.
Yes, Ramesh. Actually, try black means if you feel that if you find there is a chance of getting error, we put that particular code in the try. That's what, right?
Yeah. Which line I explained on the top, right? Okay.
Yes,
So
yes.
your code, you are dividing by a number. That
Yes,
you will
yes.
put in the try block only, because that line throws an exception.
Yes.
Or you
Mm.
you declared a variable null, and you are
Mm.
calling a null variable, your some methods are calling. Or you are converting a object into string or a primitive format. That line is a code, right? That code you will write here. So that is the how that code you need to keep in the try block. All the scenarios which are giving an exception to you.
Yeah.
The above I explained you. Those you can
Yeah,
keep in the try block.
Yes.
Okay. Now catch block. So Java catch block is used to handle the exception by declaring the type of exception within the parameter. So you have to mention exception class type and what is the reference. So you have to mention after catch block. So the declared exception must be the parent class exception, either exception class or the generated exception. So the good approach is declare the generated type of exceptions. The catch block must be used after the try block only. You cannot use alone catch block. There must be a try block, then catch block. Try catch. So that means what is meant by this is if there is an error in the try block, catch block will catch that error and that will throw that error and then catch block will execute to you. Try will skip, then catch block will execute. So because there is an error in the try block. So when catch block will execute only when there is an error in the try block. If there is no error in the try block, catch block won't execute. So that's the try catch. So you can use one try block and multiple catch blocks. So maybe your code is throwing multiple exceptions. You can write one try, multiple catch blocks. You can extend one more catch block, one more catch block. But all this, the child one, child two, and at the end, parent exception should be there. So that's how one try block multi catch blocks like this. See, catch, catch, catch. So that's the one try multi catch blocks. Then finally block. Finally block means, so it is used to execute an important code such as closing the connections, streams, anything that must be executed for you. You want to execute that block. Even the above code fails also, you want to execute always. Whether exception is handled or not, it doesn't matter. You want to execute that code. Then use finally block. Suppose your the objects you created, you want to close them. They put that closing option in the finally block, then those will be closed. So the finally block follows try or catch block. Try after you will write the finally block, or try catch after you can write the finally block. All are correct. Try catch finally you can write, and or try finally also you can write. Finally block is always executed whether exception is handled or not. Always. Because suppose try block you got an error here, then catch block will execute, right? Then finally block will execute. Suppose there is no exception in the try block, then catch block won't execute. But finally block will execute. So did you understand these two statements? There is an exception in the try block. Okay?
Yes.
Then catch block will execute.
Yeah.
Then finally block also will execute.
Yeah.
Now try block is successful, no exception at all. Then catch block will skip.
Yes.
Finally block will execute. See, finally block, both cases it is executing. Exception case also will execute. There is no exception also will execute. That means always the finally block will execute. Irrespective of exception occurred or not, it doesn't matter. Finally block code always executes. But catch block is not like that. When there is an exception in the try block, then only catch block will execute. Please catch all these points. Very, very important. When catch block will execute, when catch block won't execute. So that's a common interview question also. When there is a an exception in the try block, then only catch block code will execute. If there is no exception in the try block, that means try block is successful. Then catch block will skip. Then finally block will execute. But is it mandatory? No, not mandatory. So this finally block, catch blocks are mandatory, not required. Maybe you can write only try block. But without catch, there is no meaning, right? If you're putting a try block means there must be a catch block to catch if error occurs. That's the finally block means. A simple example of finally block. So this is the one. Try. So int number equal to 121 by 0. You know. So this line will give a arithmetic exception, right? That's why I have written arithmetic exception. Finally, I'm just writing a finally block. So number should not be divided by 0. I'm writing in the catch block. Then finally block. Finally block always executes even there if there is no exception in the try block. So now here you will get a exception. Then this line will skip. So what will happen? You got an exception here. Immediately cursor will move to catch block.
Ramesh, one dot, Ramesh. Yeah, here we know that the number 121 by 0 is an arithmetic number. So we are putting the arithmetic exception.
Right.
Sometimes we don't know what kind of error we are going to get.
Then you put a only exception class, root class. If you don't know what type of exception you are going to get, put an exception class that will take care. Then you write with this reference, you write here e dot get message, e dot get cause, e dot print status. These are the three methods used inside this catch block. Then automatically it will give you clear message, which exception it will take care automatically. So that's the how you can, if you don't know, put a root class. If you don't know what kind of exception here, you put a root class, root exception class. And that E with this object reference, you can call a predefined methods. In the exception class, predefined methods are there. Print stack trace method. It's a void method. And get message is a return type method, which returns a string type data. Get cause method. It's a return type method. They returns a string type data. So those methods you can call with this object reference. Object reference dot get cause. Object reference dot get message. Object reference dot print stack trace. These are the methods you can call in the catch block inside.
To print the exact error message.
Exact error message, it will print. This print stack trace method will print for. And get cause also will give you why that is failing. What is the reason? Stack trace means what? Complete step by step it will give you. Okay, one class. So next which class method inside this is occurring. Next which class, and line number also it will give. That's a print stack trace method will print for us. So that is this finally block advantage. So number should not be divided by 0. So that's how you got it all right. Why you need to use a finally block? Finally block is used in Java to put a cleanup code, such as closing the file, closing the database connections. That purpose you will use finally block. So when finally block doesn't execute, when the thread is no more exist, that time, and system.exit if you use, due to exception using arising in the finally block, these are the three cases finally block won't execute. Generally finally block always executes, but if these scenarios occurs in the finally block, then your finally block doesn't execute. close method. So you to close the connections or streams, you will use close method. So that's the always all the streams and the database connections, you will call close method in the finally block to close the connections. Okay, so that's the